Debugging requires a different mindset than designing, less artist and more plumber. Your goal is to subject your problem to tests that are so simple and which isolate the combined elements so visibly that you can figure out where your mental model is wrong. The ideal way to find a bug is by observing the system without changing anything. Most bugs are stupid errors, and they're often invisible because they're so stupid. So start by looking for the stupidest stuff first. Is everything plugged in the largest possible sense of plug and in? Does everything that needs power have power? Are the connecting cables actually connected? Are the parts that are connected over a network actually exchanging data? Do you have any black boxes in your project? Components, real or virtual, that you didn't build and don't have access to? Is the black box behaving as it should? This kind of bug is jokingly referred to as a high impedance air gap, and it is surprisingly common. Before you check anything else, check this. Figuring out what just changed can be surprisingly hard. One common source of bugs is the belief that changing one part of a system won't affect other parts, or that just cleaning up a program or circuit is somehow different from changing it. Any change, no matter how seemingly trivial, can introduce a bug. In order to know what just changed, you need to know the last time your project behaved as expected. This can be hard if you wait too long between tests, so the shorter the time between testing, the sooner you'll find bugs and the fewer things will have changed before you start looking for those bugs. One common source of bugs are typos. You misspell a variable, you forget a semicolon, you delete only part of a loop. The problem with these kinds of typos is that computers never ever do what you want. They only do what you tell them. And your job is to tell them, in mind-numbing detail, exactly what you want. The computer doesn't care or even understand what you meant to write. You have to learn to read your code like the computer does. Read your code out loud. If, x greater than 3, close paren. There's simply no substitute for Picayune examination. Error messages can look like technical gobbledygook, but while they typically over-report the details, they're nevertheless trying to be helpful. In particular, the first part of an error message, the line at the top of a list of such messages, usually describes the first thing that went wrong, as with processing's syntax error, maybe a missing semicolon. Even if you think you can't or won't understand the error messages, give them a careful look. If you're getting an error message, other people must have had this problem before you, and at least some of those people have talked about it in public, on sites like Stack Overflow. Even if you can't piece through the error message, a good next step is to copy the message exactly and then Google it.